In this video, we're going to be solving this problem on nonlinear inequalities in Algebra 1. The problem statement says, find all values of x, or s in this case, such that s plus 4 times s minus 3 is less than or equal to 0. So this here is an example of a nonlinear inequality. An equality where it's possible to have an s-squared term or more than one of the variable we're trying to solve for. If we were to expand this product, for example, here, we'd get a quadratic equation. So that's an example of a nonlinear inequality here. This is a bit more advanced and requires a different technique to solving than a regular old inequality would. But the good news is we don't have to necessarily deal with complex quadratic equations in order to solve this equation. This is actually quite a simple inequality to solve, because all you have to do is look at this binomial we have here, the s plus 4 times s minus 3. So if we were to treat this as something familiar, like an equation, we can write this as an equation s plus 4 times s minus 3 equals 0. And the benefit in doing this is this allows us to see which values of s would satisfy the equation if it were equal to 0. And this helps us have something to work from and help to solve the problem because we know how to start. It's kind of like a starting place. So if we go with this here equation equal to 0, we'd end up with a value of s equal to either s equals negative 4 or s equals 3. So that's two possible values there for this equation that could satisfy the equal 0. So s could be negative 4, or 3. So this could also work in the original inequality technically because it's less than or equal to 0. So, we have two values for s now, and these correspond to 2 points on the number line down here. So we can plot these 2 points, the negative 4, we're going to go ahead and add to the number line. Different color here so we can more easily see. So negative 4 is going to be right here, and then we have the 3 over here. Okay, so we have two known values for s, we can just plot right out, and what this is going to do is it's going to enable us to better solve the inequality because we have somewhere to work with on the number line now. We have a visual representation of this. So we could stop right here. We could finish the problem and write our solutions in interval notation without doing anything else because we can see our solution set. Our range on the number line is right here. And if we were to go and attempt to write this down into interval notation, we'd want to write using square brackets negative 4, comma 3, because we're including the points negative 4 and 3. That's why we have the closed circle and the closed circle on both ends. So this would be the same as saying negative 4 is less than s is less than 3. In fact, we need a line there because we have to say is less than or equal to. So we could stop right there and we could define this as our solution. But if we really wanted to be careful, and this is something that's going to be useful in more advanced inequalities, where we can't just stop solving the problem right here, for example, there may be more complex stops involved, we would need to test some of the regions within the inequality, which corresponds to the mark and test method. So as you can see down on this number line here, we've divided the number line into 3 different equations. We've got this equation right here, the negative 4 and 3, or portions that is. We've got this portion here, onwards, and this one back here. So what we're going to do is we're going to test points within each of these regions to find out whether the product, when plugged into this original inequality, or equation even, is going to be positive or negative. So we can test 0. 0 plus 4 is 4. The 0 minus 3 is negative 3. So 4 times negative 3 is negative 12. So all products and values in this region are going to be negative. You move on to the next region over here and test a point. You choose 5. 5 plus 4 is 9, and then times 2, 5 minus 3. 9 times 2 is 18, so that's going to be positive in this region. And if you check this region, negative 5 plus 4, negative 1, and then times negative 8, that's positive again. So this region is a positive. And since the inequality asks for all values of s that are less than or equal to 0, we're going to use the number line here to find the solutions to this inequality. So they want to know less than or equal to 0. That means we need to include all the points within this negative region over here, because we want our value to be negative, and then going downwards until we reach the -4. So it's going to be only this negative region here, because we only want the negative values. And this region also includes the 0, which we want because this is a less than or equal to. So you can see we choose the negative region here, because everything less than or equal to 0 is going to be negative, of course, or 0. So that's why we need to choose this negative region here, which encompasses the -4 and the 3 points. And we have the same region, and we can write the same interval notation here. So we got the same answer via 2 different methods, which means the answer is most likely correct, and that's how you would solve the problem. This nonlinear inequality question in Algebra 1, all you really have to do for this simple question is treat it like an equation first, set equal to 0, and then find the values of s that satisfy the equation. Then, plot the solutions on the number line, and from there, all you have to do is define your region, and then use interval notation to solve the problem.